Welcome, everybody. I hope you're enjoying the RIC so far. It's great to see so many friendly faces out there in the audience this afternoon. I'm excited to be here at this session. I might be as unlikely a champion for things like codes and standards as there is at the NRC, given my liberal arts background and some of the other positions I've occupied, but this has really become kind of a passion project for me over the last couple of years, and I am absolutely thrilled to be here with this really distinguished panel of experts who are going to kind of talk about this effort this afternoon. Unfortunately, you have to listen to me talk for just a few minutes, in part because I want to give you a little bit of background, and we're also going to do a little housekeeping here before we get rolling with the presentations. So this effort to kind of revisit some of our codes and standards at the NRC was something that literally John Wagner, who's the director at Idaho National Lab, and I cooked up on the back of a bar napkin one night. And John and I had worked together and known each other for quite a while. And in my role as chair at the NRC, we knew that there were a number of mutual, complementary, and really potentially overlapping areas of interest on the part of both the NRC and Idaho National Lab. Basically, places where we could work together and get some really important things done. And in the course of the evening, and it was a good evening because I don't remember how many beverages of choice were involved, but in any event, we gravitated towards this area of codes and standards, and it was based on a very simple insight, if you will, right? Which is that at least for traditional light water reactors, we know that 70% of the cost is in steel and concrete, and with advanced reactors, we have new fuel, new materials, lots of new stuff, right? TRISO fuel, the fission gases are captured in the fuel. Reactor concepts that are using functional containment. And when you start to add all that together, then you put yourself in a position to ask quite reasonably, how much of that material, how many of those materials, how much of that cabling, how much of the steel in that reactor vessel then needs to conform potentially to NQA-1 standards or other traditional nuclear ASME codes or IEEE codes, et cetera, right? The thing that I've learned, I think, in my time at the NRC is that these small things, these weedy things, sometimes make the biggest difference in kind of deployment. And I joined that, John and I kind of joined that insight with another insight from my Polish counterparts, who reminded me recently that the best time to plant a tree is 20 years ago. The next best time is today, right? And because we know, based on our experience, and we'll hear this a little bit, right? The codes and standard revision process is not the fastest moving process in the nuclear industry, but that it is actually a constant process, and one in which we can apply some additional focus today that will yield certainly near-term results that we're going to hear about, but also results potentially down the road that when it comes time to go put a shovel in the ground to make those orders for those key components, those valves, those pumps, those motors, the cabling, et cetera, that a revisiting of these codes can really make a big difference. And this is this was an initiative, Michelle, I don't know, what, a year or so, 18 months ago or so, right? And so, look, we had a kickoff meeting, and Michelle Sampson, who was then in the Office of Research, and Jess Guillen from Idaho National Lab came, and we had folks from industry in, and we kicked this thing off and said, okay, and they came up with a plan, and we had, you know, like all good plans, we had 3 buckets and things that we could accomplish in the near term. And Michelle certainly got us off to a great start. And then Christian Araguas has picked this up, and Chris Cook is here to fill in for Christian today. And I'm so grateful to our folks at the labs, our collaboration with industry, with ASME, with NEI, with EPRI, and others, and our licensees and applicants on this effort, and the way that folks have embraced it, and the way it's really been internalized and led in the NRC staff. And so, as I said, we had the action plan. We've had a number of public meetings on this. The ADVANCE Act, of course, really helped this because there was Section 401 about the manufacturing and construction of advanced energy projects, advanced nuclear projects, and we in January we submitted the first report of that, and I think that's going to be the subject of Michelle's discussion, and we just had another public meeting in February on commercial and maybe non-traditional codes that could be applied to the nuclear industry, right? Think oil and gas, refineries, et cetera, things that might be of use. And so this RIC session is really a continuation and hopefully a little bit of an exclamation point on a lot of these efforts, even as we kind of are poised to move forward. So before we get started, let me do the housekeeping, which I am not good at. However, the Wi-Fi code, I think at this point, Wednesday afternoon, people are getting the Wi-Fi down. The Wi-Fi code is RIC 2025, all capitals. I'm supposed to remind you to silence your phones. We are going to have a Q&A session. You can do that by scanning the QR code, and I'll get it up here on the iPad. And but we'll also, folks will be able to, stand up and shout too. So, so there's no worries about that. For those joining virtually, there is going to be a box apparently on the right of your screen, and so that stuff will also show up on the iPad. And so looking for that. We're going to have 2 live polls during the discussion this afternoon. So I think the first one is going to be after Chris's presentation. And you can, apparently, for in-person participants, you can text the code next to their choice of 22333. Okay, I'm getting the thumbs up over here from Robert and Mirage, so that's good. And then I think for the folks joining virtually, there's a button somewhere that you can, like a tab, that you can use for that. So we'll leave the QR code up for a little while so folks can scan that, and off we go. So with that, all of that taken care of, now let's get to the good part, right? And our first speaker is Dr. Christopher Cook, and he's going to be talking to us about NRC's action plan to enhance our codes and standards program. And Dr. Chris Cook is a special assistant in the Division of Engineering in the Office of Research here at the NRC, and during his 18 years, Chris has worked in a variety of diverse roles as a permanent supervisor of technical branches ranging from safety assessment of external hazards to digital instrumentation and controls and cybersecurity. He's also worked as an executive technical assistant in the Office of the EDO. And Dr. Cook's technical expertise is in external natural hazard assessments at nuclear power plant sites, particularly the analysis of flood-related hazards and thermal impacts to the aquatic environment. Dr. Cook holds a bachelor's degree in civil engineering from Colorado State and a master and doctorate degrees in civil engineering from the University of California at Davis. He's a licensed professional engineer in the state of Maryland. So Chris, over to you.
Thank you very much. Appreciate it. Perfect. Just making sure I can figure out the remote. I think we've decided we're going to stay informal and stay seated, so I'm going to stay here and do that. And thank you for that. I think that makes things a lot more comfortable. Well, good afternoon. Thank you for that introduction. I'd like to first take a minute to mention that the Office of Research is a partner office that provides support to all the business lines across the agency. Research staff have a wide range of technical expertise and a variety of disciplines to ensure the agency's readiness to tackle complex issues that face the operating fleet, as well as new and innovative nuclear technologies. This includes NRC's standards program, which is run under the division of engineering under the direction of Christian Araguis, as you heard, who is also the agency's standard executive. So my presentation today is about an initiative that's underway to enhance that codes and standards program. Consensus codes and standards are essential to the NRC licensing process, offering a framework that ensures regulatory stability and consistency across diverse regulatory actions. By adhering to consensus guidelines, licensees and applicants can be evaluated more efficiently by the staff, especially if graded approaches are used that incorporate risk and performance-based insights. Use of voluntary consensus codes and standards instead of government-unique standards is actually required by the National Technology Transfer and Advancement Act of 1995. Use of consensus codes and standards is also aligned with NRC's principles of good regulation, particularly in the area of openness, clarity, and reliability. Application of NRC-endorsed consensus standards also increases the potential for approval efficiency during first-of-a-kind licensing. Endorsement also supports the potential for large-scale, high-volume licensing by providing clear regulatory expectations and reducing uncertainty. Participation by agency staff in standards developments fosters collaboration among various stakeholders, which facilitates a more efficient regulatory environment that prioritizes both safety and innovation within the nuclear sector. The NRC maintains a robust codes and standards program. The program has approximately 180 dedicated staff currently in the program. And while the program is led out of my division in the Office of Research, it is truly an agency, it truly has agency-wide impact. The professionals that participate in the Codes and Standards program externally coordinate across 36 different government agencies, as well as 12 different standard development organizations. As of today, NRC staff are contributing to the development of over 200 new or revised codes or standards through these organizations' activities. This is accomplished by staff's active participation on various committees and work groups along participants from academia, research institutions, vendors, and utilities. Staff participation in this program ensures that the agency remains informed on the latest technological advancements and best practices in the industry. To date, the NRC staff have issued more than 380 regulatory guides that endorse consensus codes and standards. There we go. While the existing codes and standards program has served us well, we listened to stakeholder feedback that the program may not be positioned to serve us as effectively and efficiently in the future. In February 2024, the NRC and the Idaho National Laboratory issued a coordination plan with the objective of sharing expertise, sharing knowledge of codes and standards development, and identifying opportunities to enhance NRC's codes and standards program to strategically benefit new and advanced reactors. Then in April 2024, the NRC and the Idaho National Lab co-hosted a public workshop to gain insights on high priority standards needed for future development of new and advanced reactors. We also wanted to get ideas about program enhancements so that we could explore how to improve NRC's program. Workshop feedback noted that today's endorsement standards are predominantly focused on large light water reactor designs and rely primarily on deterministic approaches. We also heard that the stability benefits afforded by the use of the rulemaking process may not be advantageous for advanced reactors seeking endorsement in the near term. Finally, we heard that many of today's endorsed standards do not facilitate efficient construction or the rapid large-scale deployment envisioned by today's new reactor developers. Staff recognize the evolving desire for endorsing more technology-inclusive codes and standards that accommodate the diverse landscape of nuclear innovations, particularly for the advanced reactors. Bold and innovative solutions are needed to more quickly endorse high-priority codes and standards if the NRC program is to remain relevant, timely, and effective. An enhanced codes and standards program should promote the inclusion of graded approaches that utilize risk and performance-based insights to allow for a more tailored regulatory process that aligns with the unique safety profiles for each new technology. Finally, NRC's program resources should be strategically refocused by prioritizing staff support to high-priority standards initiative, informed by external stakeholder feedback, to ensure the program remains responsive and aligned with industry's advancements and future licensing submittals. Based largely on input from this workshop, the Codes and Standards Action Plan was issued in August 2024. This plan identifies key areas for improvement, focusing on increasing timelines and efficiency while promoting risk and performance-based insights. It comprises 17 items categorized into 3 program areas. The figure on the left of the slide illustrates the makeup of the plan's components. The action plan's implementation involves a phased approach with defined timeframes that include swift actions for activities to be completed within 1 year, intermediate activities for activities to be completed over 2 to 4 years, and ongoing program enhancements aimed at sustaining long-term improvements. Over the next few slides, I will dive into each of these 3 program areas to discuss specific enhancements we've accomplished to date and their latest status. The first enhancement area is on development process improvements. This area aims to focus NRC staff's participation on high-priority standards and development activities. Enhancements in this area also include solicitation of external input to inform NRC regarding which consensus standards should be considered a high priority and might benefit from enhanced NRC staff engagement. Accomplishments in this area include an improved understanding of the results coming out of the industry's needs assessment survey, as well as other related ARTSIC activities. And you'll hear more about this from Kate Hyam in just a few minutes. The standards program also issued letters to ANS, ASME, and IEEE in February requesting their input on codes and standards that they considered a high priority need for the new and advanced reactor community. These inputs plus our own insights will enable the staff to publish a priority list of standards, committees, and work groups for enhanced NRC engagement by the end of 2025. The second enhancement area focuses on NRC's endorsement processes. This action plan items will create more explicit guidance for endorsement to foster greater transparency and perhaps a graded approach to the endorsement process. Our plan is to test and pilot several process efficiencies and as an intermediate activity over the next 2 years. Another intermediate activity is an update to Management Directive 6.5. This directive, which is a public document, contains NRC policy governing participation in the standards program and use of consensus standards. This is a document we plan to update to preserve new endorsement efficiencies that result from endorsement pilots, from the pilots that we go through. One accomplishment in this area is how staff were able to expedite their endorsement review of a code case supporting ASME Section 3, Division 5 on high-temperature reactors. Staff took steps to proactively complete the technical basis research on alternate approaches for non-destructive examination and testing while the 2023 ASME Code edition was being developed. Staff were able to maximize their participation in code committee meetings and leverage information from those meetings to inform their technical basis for endorsement. By working proactively in this way, staff completed and issued a draft reg guide in under a year, likely shaving off 1 to 1.5 years to get to the same stage in the endorsement process. The third enhancement area focuses on leveraging commercial standards. This area evaluates the potential use of commercial or non-traditional standards. As alternatives to the traditional set of standards for licensing of large light water reactors, the advanced reactor community has identified commercial or non-traditional standards for potential use based on the relative risks of their structures, systems, and components in the design and their limited impact to safe plant operation and the public. A recent accomplishment in this area was NRC's hosting of a public meeting on February 11th. The purpose of the meeting was to kick off Swift Action 3.1 to solicit input on priority commercial standards for the advanced reactor community. We also used the public meeting to clarify the action plan's use of the phrase commercial/non-nuclear. During the meeting, we heard the advanced reactor community's strong desire to use numerous alternatives to their traditional large light water standards during future licensing activities. Presentation from several advanced reactor designers and vendors provided specific examples of standards that they were targeting for potential use. And this information was both timely and useful for us as we move out to implement several action plan items. If anyone missed this meeting, the meeting summary and the meeting's transcripts are both public documents. So this is my last slide, and I wanted to wrap up with a few summary remarks on the next steps for NRC's Codes and Standards program. As you heard, the action plan enhancements are well underway. We have achieved several accomplishments, and I want to thank the part-time advisory team from multiple NRC program offices that have helped to make this happen. I'm happy to report that all SWIFT actions are on track for completion during 2025. The team is also making great progress on many of the intermediate activities and the ongoing program enhancements. Although each of the 17 action plan items are separate items, each one works in concert with the other to enhance the overall Codes and Standards program. Finally, I'd like to put in a plug at the end to talk about NRC's Fall Standard Forum. This is the annual event that will be hosted once again by NRC here at headquarters this coming September. And with that, thank you very much.
Great, thanks, Chris. Well done, and I'm a big fan of shameless plugs myself, as you all know. With that, I'm going to hand it over to Mirage for just a second here because we've got our first polling question. So, Mirage, why don't you take it away?
So that's the first poll question, and remember that the text, the code that is next to the answer to number 22333. So the first question, regarding the new and advanced reactor technologies, which of the following potential enhancements to the NRC Codes and Standards program should be given the highest priority? A, expand staff participation in nuclear codes and standards working groups, such as ASME Section 3, IEEE, NPEC. B, expand staff participation in commercial, such as non-nuclear construction DOE standards, codes and standards, working groups. C, add public meetings beyond the RIC and Fall NRC Standards Forum to update staff on changing priorities for new revised codes and standards endorsement. And the last option is develop efficiency for the NRC endorsement process, such as augmented use of interim staff guidance, white papers, and expanded public meetings. Again, please text the code next to each option to number 22333. Wow, so far, this is option D, 77%. Okay, 67%. Option D, still, yeah, seems that's the highest percentage. Option D so far. Okay. Yeah, it seems option D is the winner, 55%, followed by option A in the second place, and option B third, and option C fourth.
Thanks. Yeah, that letter D, deeply develop efficiencies for the NRC endorsement process, et cetera. I think that's, we can, as we get into the Q&A session and as we make our way down to Michelle down there at the end and come back around to Chris, I think we can probably tackle some of that too. And maybe you can give us an update in a few minutes, Mirage, on
Yep.
the final results of the polling, and we'll move on to our next presentation with Dr. Jennifer Ewell.
Okay.
She'll be presenting on efficient development of risk-informed codes and standards for new reactors. Dr. Jennifer Ewell is the Vice President of Technical and Regulatory Services at the Nuclear Energy Institute. Prior to joining NEI, Dr. Ewell served as the Director of the Reactor Safety Programs at Jensen Hughes. Dr. Ewell joined Jensen Hughes in 2016, working in advanced reactors, thermal hydraulics, and regulatory affairs. Previously, she served at the NRC for 23 years in several positions, including the Deputy Director of the Offices of Nuclear Reactor Research and Nuclear Reactor Regulation, and the Director of the Office of New Reactors. She obtained her bachelor's and doctorate degrees in nuclear engineering from the Massachusetts Institute of Technology, I think I've heard of that, in 1991 and 1996, respectively, with a specialization in reactor systems and design. She served as the U.S. representative to the International Atomic Energy Agency's first fact-finding mission to Fukushima in 2011. Dr. Ewell?
Okay, thank you very much, Commissioner, and I apologize for the long version of the bio. I will do better next year if I'm invited back, that is. So I think we can all agree, no matter what everybody's politics may be, that the nation needs a whole lot more power. We need to keep our grid stable, we need to keep it reliable, and we've got to address the skyrocketing demand for power. Commissioner Caputo mentioned the number of plants the nation needs to build, and with design and construction, obviously comes the need for codes and standards. And I do have to say, of all the topics associated with nuclear power, codes and standards has to be the driest topic of all time. However,
I'm trying over here.
it is one of the most important and can really expedite NRC approval of designs and also facilitate construction. So I just wanted to kick that off. I appreciate everybody's interest in this topic because it truly is very important. So obviously with new materials and fabrication methods and the need for, I would say, rapid deployment, we really need to focus on updating our codes and standards, as the Commissioner indicated. There's a number of industry actions and combined with the NRC participation in the development of new codes and standards and expedited endorsement of critical code cases, and I'm going to provide a few examples. But in addition, as this Christopher pointed out, we also need to think about using risk insights. So we're focusing time and attention on really what is most important to safety, which benefits us all. Why? Because it can improve efficiency, it can also improve safety, and it can also keep costs down, which can help us deploy new nuclear power plants, which, again, are good for all of us with its clean attribute. So if we go to our first request from the industry is NRC endorsement of code case N883. And so I hope everybody brought their ASME code decoder ring because we got a lot of code cases. So this one is actually an issue right now, and that is the issue about manufacturing of components ahead of time. And that means manufacturing without an owner, and without an owner being a licensee of the NRC. So ASME Section 3 permits it for valves, pumps, supports that are less than 4 inches. Not totally clear why. Could have to do with the fact that these components were going to be used very frequently. You didn't need a big design spec, complex design spec, and that's how it was done. Code case N883 removes this size limit, and that would help us. We could get components on the shelf. They would be, of course, fabricated by an N-stamped manufacturer. It would be essentially, quality assurance would be double-checked by ASME authorized inspectors. And then when an owner takes ownership of that component, the QA programs then also apply. So we think this is a way to go forward. However, there's a legal entanglement here because without an owner that's a licensee, NRC doesn't have jurisdiction here to take enforcement action. There isn't a safety issue here. Both the industry and the NRC agrees on that. It's a legal entanglement. And, we do find ourselves, both the industry and the NRC, getting ourselves in these situations where it is not a safety issue, but we can spend years trying to untangle, the legal nuances. So I know the NRC is working on this as well as the industry, but we really need a speedy resolution of this to enable deployment. It's just mandatory. When you think about how long the backlog is to get, say, a reactor pressure vessel, it's like 6 or more years. Even on the non-safety side, turbines that are used in at every power plant, virtually, they're also getting backlogged 6+ years. In order to deploy the way we need to, we have got to solve this. So it is a plug to get to that. The next code case here, or excuse me, code case is N940, which is Div 5 of Section 3 for high-temperature components. Really what we're trying to do here with this code case is to use risk insights so that the design and manufacturing can be applied with a graded approach, and there's more time and attention focused on those components that are more risk significant. We do this quite often in the LWR fleet right now with 5069 and other risk-informed completion time is another approach, not looking necessarily at the quality or the risk significance of the component, but the risk significance of the plant configuration. But nonetheless, we've got a lot of history of doing risk-informed processes well. And we think this one is another one that can really provide some benefits. It's going to enhance safety because time and attention is going to be focused on those components that are most safety significant. Right now, with this code case, the NRC staff, at least from the industry's point of view, has added some limitations on this code case. We don't quite understand the safety basis for those additions, and it ends up undermining the benefit that would be provided by this code case in terms of efficiency, but also the additional safety benefit by adjusting our time and focus on what's most important to safety. So a request here comes in for this code case to be endorsed without those limitations. We also have another issue here. It's kind of like dueling volumetric exams. I am not a materials engineer. However, I stayed at a Holiday Inn Express last night. I spoke to a couple of materials engineers and NDE technicians. And UT and RT, ultrasonic testing and radiography, are both volumetric exams that are very effective. Well, Section 3 requires radiography for construction inspection. Okay, when you do radiography, you bring in a source, you've got to clear everybody out of the area, it's more time-consuming and burdensome inspection. But what's interesting is now when you go to Section 11 of the ASME code, the pre-service inspection is UT, ultrasonic testing, another volumetric, reliable volumetric examination. And in addition to this, there's different repair criteria for Section 3 for the RT and Section 11 with the UT. What we're recommending here is that we just go to UT. We've used UT for as long as it's been available. We can digitize the exam to save for the records if people need to go back and take a look at that. It provides a baseline form of inspection of a component so that when there are degradation mechanisms that rear their ugly head, we have a baseline there. And why are we duplicating a volumetric exam? Doesn't make a lot of sense to us. So we do request that we get to the point where we're just using UT for both construction, inspection, and pre-service. The next one here is efficient and effective civil structural codes. I spoke to a well-known professor in structural engineering, been involved in a number of the construction codes, and he said, really, the cost of building nuclear is about 4 to 5 times higher than any other structure, not because of more rebar or because of more concrete, but because of the quality assurance requirements. And again, we go back to, why are we doing this? And especially with the enhanced safety profiles of these plants and our ability to determine what part of the system is more safety significant than others, it'd be great if we could use some high-quality, high-reliability options rather than always going to the nuclear code and standards. Would reduce the cost of design, it would help with deployment, and often the quality assurance is just extra time away from actually doing the hard work of the construction. We're still going to have quality assured requirements here because these codes have been used with hospitals and other high reliability structures, so we don't see this as being a detriment when used wisely. So codes and standards that are risk informed and leverage technological advancements are going to be key here. I've listed what our key priorities are. There are others. We only had a few minutes to talk, so I'm not suggesting I want more because I am not a codes and standards expert. But nonetheless, industry and NRC support for codes and standards it's absolutely critical for enabling efficient and timely deployment of the new generation of reactors. And it's all of us are involved in this. We need to get this done, and we need to do it efficiently. Thanks.
Thanks, Dr. Ewell. Appreciate your presentation. Mirage, do we have an update on the poll by any chance? Okay.
Can you display? Yep.
Yep.
Yeah, option D still
Okay.
leading.
All right. Very good. Thank you. Just wanted to check in.
Okay.
All right. Next up is Kate Hyam. She's the Director of Nuclear Clean Energy and Standardization Codes and Standards at ASME. She's responsible for ASME's portfolio of standards applicable to nuclear facilities and non-nuclear design and standardization. To support the deployment of advanced reactors throughout the world, she's involved in the codes and standards related efforts under NEI and EPRI, under the NEI-EPRI roadmap, as a former co-chair and current member of the Advanced Reactor Codes and Standards Collaborative, or ARCSC, and as a member of the IAEA Nuclear Harmonization and Standardization Initiative. So, Ms. Hyam, over to you.
All right. Thank you very much for that introduction, and thanks for the opportunity to talk to you today about the Advanced Reactor Codes and Standards Collaborative and all of the work that we have undertaken to try and prioritize codes and standards for advanced reactors. I'm very slide-rich today, so you'll see a lot of things flow through. If you want to read it, you can read it later. So the first thing I'd like to point out is that the ARCSIC work, that's what we call the Advanced Reactor Codes and Standards Collaborative, is in alignment with the NRC Advance Act. We are working to accelerate deployment of standards deployment of advanced reactor technologies by updating existing and developing new standards to meet the industry needs. This will offer NRC the opportunity to accept existing codes and standards where applicable, And we believe it's complementary to NRC's work and avoids duplication of efforts. So today I'm going to give you a really high-level overview of who ARCSIC is, what we've accomplished relating to those prioritization of standards, and what we hope to accomplish in the future. So first, a little background. To reiterate what Chairman Hansen, or what Commissioner Hansen just said, with the support of NEI and EPRI, Standards Development Organizations, also called SDOs, led by the American Nuclear Society, the American Society of Mechanical Engineers, and CSA Group, established ARCSIC to execute codes and standards actions that were identified in the North American Advanced Reactor Roadmap. This group was founded in 2022. Since the initial formation, participation has expanded from just being SDO, Standards Development Organizations, beyond that to international organizations and advanced reactor developers are included as well. Our mission, again, is to ensure standards support large-scale advanced reactor deployment, and we actually have 4 objectives or goals. We want to make sure that we are sharing information between SDOs and industry. We want to identify and gather advanced reactor standards developer needs. We want to inform and complement other international efforts such as IAEA's nuclear, NESI, and WNA's Cordell. And we want to align actions with the Advanced Reactor Roadmap Implementation Board. So some of the activities, the first 2 we were assigned as part of the Advanced Reactor Roadmap. The first one is to identify gaps in current standards and timelines for completion of advanced reactor codes and standards. I'm going to be talking a little bit more about that after this slide. And our second activity that we were assigned was to demonstrate risk-informed and performance-based approaches. So ARCSIC meets about every 2 weeks, and throughout the last year we've been hearing presentations from many of the different SDOs on how they're addressing risk-informed performance-based. Most SDOs, in fact all SDOs, have some component of that already embedded in some of their standards or are in the process of developing it. So where we think we're going with that particular action item is to develop a white paper identifying what each SDO is doing in that arena and making that available to the public. We also have a yearly workshop, usually held at the end of November, early December, to update everyone on the current process and progress. And we also have a website. You can go to that website, and it'll provide you with presentations from past workshops, all of the standards committees that work on nuclear codes and standards, and also contact details if you are interested in becoming involved in any of that standards activity. So please feel free to go to that website and find out more. Okay, so now I'm going to talk about our prioritization, and the first step in prioritizing codes and standards was to determine the codes and standards needs. So we developed this process, shown in this diagram, on how we were going to go ahead and tackle that task. So the first thing we did is we looked at all of the nuclear standards developers and had the SDOs identify standards that were used in the nuclear industry. We also identified current activities underway within those standards committees. And we initiated a survey in 2023 that asked for feedback specifically on those nuclear-related standards, and also offered the opportunity for the industry to identify any gaps, either within those standards or just in general. We did collect all of those responses, and we sliced and diced the data and sent that data to the standards development committees for their review and potential action. If you go to our website, all of that information is actually posted there. So if you can, as you can see here, we parsed all of the information out so that it was committee specific, and we asked each of the committees to go ahead and take a look at each of the gaps that have been identified by industry participants and to look at it and say, is this truly a gap? If it was it persuasive? Not persuasive, not really applicable. If it was persuasive, then what action are you as the committee going to take to make sure that you have met that gap, that you filled it? Optionally, we asked them to give some completion dates and anticipated resources. Is there more research that's needed, et cetera? And finally, the SDOs prioritized those gaps that were considered to be valid, and we did a high, medium, low. High was really for those that were addressing licensing needs or design, and the medium and low were ones that might be needed further on in the development of these advanced reactors. So I'm going to give you a couple of examples of what was identified for American Nuclear Society. You can see there were a number of standards that had gaps identified in the realm of seismic design, radiation shielding, and quality assurance programs. Similarly, for ASME, we had gaps identified in Section 3, Division 1 for seismic, Division 5, high temperature materials and graphite requirements. We also had operation and maintenance and QA. I will note that a lot of the QA items that were identified were questions, and there is a session tomorrow on quality assurance where I think you might have some insights and answers there. Additionally, we had ASCE. The feedback that we got for their standards was that there were no specific priorities identified per se, but there was a need to update the standards and really consolidate their ASCE, SEI 4 and 43 into one standard. So there were priorities set by the SDOs based on that initial input, but we really needed to verify that that's what the advanced reactor developers and designers felt. So we developed another survey that asked each of the reactor developers to indicate if it supported design efforts, licensing review, component fabrication, facility construction, or would reduce OM costs. We asked them to prioritize the identified gaps and provide additional comments on those gaps. And then finally, we asked them, how soon do you need it? Next year, 10 years from now, let us know. So that validation survey went out last fall in about October timeframe. It was open for about a month and a half, and we specifically targeted 38 advanced reactor developers from 20 different advanced reactor companies. We did receive 14 responses, and you can see who's responded here. So the results largely supported the SDO priorities with some refinements. So you can see this is an example of BPVC 3, Division 5 high temperature reactors responses, and what we were able to do is kind of rank the different gaps that had been identified in order of importance. So you'll see graphite, high temperature materials kind of at the top, and some more nuanced items further below. And we also were able to obtain a lot more comments, which is important feedback for our committees to be able to make those changes. Similarly, American Nuclear Society 2.26, some of this can't see very well, but they were able to indicate that for that particular standard, majority of the advanced reactors responding wanted that available in 3 years, and again, they received a lot more comments on that. Just noting that we also had CSA in our all of our surveys. And then finally, well, it should be noted that the work has already been begun on the standards development side. So all of those gaps that had been identified were sent out to all those committees, and the committees have already picked that up and started working on it where they could. So this just shows you that ASCE 92, which is that consolidation of ASCE 4 and 43, that work is underway. They hope to have a full draft available by the end of 2025. And if you want to go to the Building the Energy Future session tomorrow, I think that's going to be a large part of Andrew Whitaker's presentation. Similarly, IEEE had no real high priority items, but they are working on all of their nuclear-related standards. They do have a lot of AR developers. that are on their committees and helping them to advance their standards to meet those advanced reactor needs. So it's kind of a two-step. We can prioritize, but also we need assistance to make sure that we've got the right people in the room to make sure that the standards are updated in the right way. Okay, so we have identified standards gaps, we prioritized them, we verified our high priority items with those reactor designers, and now we are compiling the final list of high priority items that may require additional funding or research, or additional resources. Maybe we need some additional expertise on the committees in order to revise those existing standards. That report will be going to the North American Advanced Reactor Roadmap Implementation Board, and also we have been requested, as noted earlier, for input directly to the NRC. So we will be gathering all that information and getting that over to them in mid-April. Okay, we do know that there are other areas that might require gap assessment. Here's just a few. You know, we tackled the ones that we knew were nuclear related, but there's a lot more out there, and this could be topics of future ARCSIC action. What we do know is that we are going to be evaluating the need for action on those non-nuclear commercial standards and whether or not ARCSIC is the place to take that action. Again, we're analyzing the survey results in order to get a good response to the Roadmap Implementation Board and NRC. We are looking to broaden ARCSIC membership to better engage with advanced reactor community. And we encourage advanced reactor community to actively participate at the SDO writing level. We need your participation on the committees. We are looking to seek resources and funding to expedite standards development and support the industry in the use of risk-informed performance-based methods. And finally, we may be addressing harmonization of codes and standards as part of our activities in 2025. And that is all I have. We welcome your participation, your feedback, your thoughts. You can contact anyone on this list. I am, Don Eggett is our current ARCSIC chair. I'm the most recent past co-chair, along with Larissa Logan from CSA. We have Pat Schroeder as our secretary. Mark Richter and Frankie Pimentel from NEI are working on this, as is Andrew Souter from EPRI. So you can contact any one of us for more information, and thank you very much.
Thank you. A lot of really good, important work going on here. Thanks again. Next, we're going to hear from Steve Unikowicz. Did I get that right?
Close enough.
Oh, man. All right. Well, he's a chief engineer of plant engineering for TerraPower's Natrium plant. He has over 42 years of commercial nuclear power experience, and he worked at a whole variety of places, including Connecticut Yankee and Millstone as a design engineer, the NRC, Allianz Science and Technologies, NuScale, Vogtle Units 3 and 4, and Idaho National Labs. He's an American Society of Mechanical Engineers Fellow, a member of the ASME Board on Nuclear Codes and Standards, as well as a member of the ASME Operations and Maintenance of Nuclear Power Plants Code and Qualification of Mechanical Equipment Codes and Standards Committees. Whew. Steve, over to you.
Thank you. So I appreciate where I am in the lineup today because I think it works fairly well. To be fair and to be very transparent, I've worked very closely with Chris's organization. I was part of the recent ARCSIC and NRC public meeting in February. I worked fairly close with the NEI folks, with Jennifer. I know enough about Section 3 and Section 11 to be dangerous. However, I kind of turned it over to one of my other chief engineers. I am a member of ARCSIC, so the things that you've seen from Kate, I am a little bit more than I wish to care about, that I know about, and we work very closely over the years. And from a practical point of view, as we said, I am a plant engineer, so I am the practitioner. Where we are and is that we are both in the actual practicing of these codes and standards from today's point of view, and we're kind of looking also to the future. So where is Natrium? I know you heard Chris Levesque earlier today. I'm going to try not to repeat stuff that Jennifer talked about, stuff that Chris talked about, and stuff that Kate talked about, so I will try not to do that. So where are we? Well, we are designing our plan for 60 years, which can be a challenge from a code and standards point of view. We do have a 40-year, 51 limitation on new licenses. We also have some things in there that regards our 34 years, which really we'll talk about a little bit, and Jennifer kind of mentioned it, the Section 3, Division 5 stuff. And yes, we are working very closely with NRC staff. I do want to talk a little bit about action plan item 2-3. So when I talk about opportunities, these are both opportunities and challenges both at the same time. We did talk about commercialization of commercial nuclear codes and standards a couple weeks ago. I'm really not going to repeat all of that stuff. Our hard part is we have nuclear island, we have a salt island, and we have an energy island. So how do I deal with a similar code and standard from 3 different very similar systems? It can be a challenge at time. When we talk about resolution conditions during code meetings, that happens. That happens a lot. And you probably haven't heard that, but I will tell you from an up-close and personal point of view, OM2 was a fantastic success due to NRC staff interaction. QME1, hopefully 2025 will be coming out, was a great success because of NRC interaction. We truly did resolve all of our open issues. With Dr. Rutland in the audience, from a board new code standards point of view, we work very closely with staff. From an ASME perspective, maybe not some of the other codes and standards, this truly has been a success. We're going to be endorsing OM2 with a red guide. We're going to be endorsing IEEE 344 2020 with a red guide. It truly is working well. Much to people's surprises, it's working. Efficiency gains. I think there can, regardless, I think there can be some efficiency gains. We do have a lot of limitations and conditions. Some of them are easy, some of them are hard. And quite honestly, I'm former NRC staff, we didn't always agree with industry. That's where limitations and conditions come into play. We do get through them, though, I must say. The more we get through those conversations, the easier it is downstream. Again, I think in OM2, on QME1, we resolved all of them. Those should go through relatively quickly. What does it kind of do? Well, I think a couple things. One, it reduces, for me, a project risk. If I know up front what's coming ahead, I can design my plant to address NRC staff concerns. And honestly, that's what's been happening with QME1, OM2, and a number of the other standards, AG1 and QA. We're kind of working up front, and we kind of really know what's going to go on before the standard gets published or before it gets endorsed. That truly is a help for us. So while we're going to talk about some opportunities and challenges, there truly are some good things happening here in the world. Harmonization. Harmonization is a difficult issue for us. And why is it difficult? Because it's harmonization both from the IAEA standards and as well as through codes and standards with ASME, through IEEE, through all the rest. Guess what? They don't agree. Guess what? Red guides don't agree either. I have 3 different red guides that endorse 3 different versions of the code, and now I'm dealing with 2016 versus 2020 and sometimes 2008, and I truly try not to cherry pick, but sometimes I do, because I have to get a plant built. And truly, I'm building a plant. As you heard Chris this morning, we're building a plant. So we need to put the fork in it, and so let me go on. Let me talk about the impact and quality classifications. Codes and standards are deterministic in nature. They're not risk-informed in nature. This, by the way, is very difficult. We argue much too often what's risk-informed, what's performance-based, and how we deal with them. Not all codes and standards are performance-based. What do I default to if I can't do performance-based? Well, I default to deterministic. Why? Because sometimes deterministic is the better way to go. Not all things are PRA. I'm sorry, they're not. Some things we truly need a good mechanical deterministic approach to things. And we do that. I think we struggle with it, but I'm telling you we do. There are some pieces, seismic interactions, some of the pieces where we are going to go to deterministic standards. The other part to this is PRA and design are not always in lockstep. You know, I would love to have a full-blown PRA done, then I could do reliability targets, and then I figure out how I'm going to qualify equipment. It truly would be great. The reality is, it doesn't happen. I don't have 40 years of experience with sodium valves. I don't. How am I going to deal with that? Well, I am. I'll just leave it that we are. So we do have challenges. Do I think codes and standards can get there? Maybe. I think there's a balance. I think there are some that need to be probabilistic, others that don't. You're asking me as a practitioner, I'm just telling you how I'm going through things. We have this non-state related special treatment. It's a feature, not a flaw. By the way, we've been doing this for 40 years. If anybody thinks that NSRST and NST is something new and special treatment is new, it's not. We've been doing it for 40 years. Right waste QA, fire protection QA, ATWAS QA, written since 1996. It's not new. I'm not quite sure. It confused the heck out of me why people think this is a new item. It's not. Special treatment is special treatment. I will tell you that from my perspective, what we've done in OM2, what we've done in QME, is we have decided that all of our codes and standards are function-based. What does that mean, function-based? If it means the valve has to be open-closed or has to close in its important safety position, that's what I qualify it to. That's what I use codes and standards to. I don't apply it to all things. If it modulates and it's not an NSRST function, we'll figure out a different way to do it, probably with the commercial standards. So function-based, put that in your mind and think about it. Function-based performance, that's what I'm looking for. Why? Because that truly is what safety is all about. It's about function-based. So it truly is a feature, not a flaw, and how it all works together. NEI 1804, we've been struggling with it, and yes, the reality is we are struggling with it. And we're struggling with it, again, for the reasons that I mentioned. PRA is not keeping up with design. So how do we do these in parallel? We will, by the way, and we'll get it done, but sometimes PRA doesn't precede design. Design precedes PRA and how we do it. And we are using LMP, and we will be a success at it. Again, I did kind of mention special treatments a few slides ago. And again, they're not new. They're not. But what is the goal of special treatment? The goal of special treatment really is to put the quality assurance and importance on those things that are truly important. Do I care about AOV stroke times? The answer is probably not. Does the performance safety function stroke time? Probably not. So with our new codes and standards going forward, we're not doing that. We'll use condition-based maintenance, and we'll look at those things that are important to safety. I'm going to repeat that a couple more times so people understand it. Function-based, important to safety. And it truly is a systematic approach. It's not it's component-based, but it's systematic-based. It's system-based. I'm really not going to read all of these slides. They tend to be a little wordy, and I think we'll run out of time. I prefer to answer questions. We do have a code of record. We are putting a fork in it, and we will say we are done. And yes, we're looking for plants 2 through 10, hopefully. And yes, I think some of the recommendations, lessons learned from Unit 1 will apply to Units 2 through 10. We'll see how that kind of goes. Let me get through Plant 1 first, then I'll tell you how it goes. Lessons learned. Again, I've kind of already mentioned these that we're already talking about. We do struggle with LMP. We do struggle with design and PRA going on at the same time. It's difficult sometimes to communicate risk-informed license basis between the applicant and regulator because it's not the same language. By the way, I use the same word in 3 different groups, and it means 3 different things. By the way, that goes also to the harmonization piece. The same word in Section 3, the word in Section 3 means something different in Section 11, means something different in AG1, means something different in QME, means something different in OM. We don't always speak the same language. Not quite sure how to fix that. It'll be what it is. We do have a small footprint to our advantage. Well, that'll help out at things. I really didn't have a lot more to talk about perhaps we'll get through some of this during the questions. I kind of want to give you sort of a high-level overview of where I am and where we're going. We have a couple of years to get this done, and we will. So function-based probabilistic risk assessment, function-based. So with that, I will turn it back over to you, Commissioner.
Thank you very, very much for your presentation, Steve. Our final speaker is Michelle Sampson. Michelle Sampson currently serves as the Director for the Division of New and Renewed Licenses in the Office of Nuclear Reactor Regulation. She joined the NRC in 2007 and has since then served in various capacities from project manager up to division director throughout the agency, including in the offices of Research, NSER, NMSS, and EDO. Prior to joining the NRC, Ms. Sampson worked at the Department of Transportation and at the Paducah Gaseous Diffusion Plant. Ms. Sampson is a graduate of the University of Tennessee at Knoxville and Murray State University. She will present on the ADVANCE Act Section 401 report on advanced methods of manufacturing and construction for nuclear energy projects. Michelle, the floor is yours.
Thank you, and good afternoon. I appreciate the opportunity to be here today to discuss the requirements of Section 401 of the ADVANCE Act, the report on advanced methods of manufacturing and construction for nuclear energy projects. As you've heard in several sessions, the ADVANCE Act represents bipartisan support for the agency and assists the NRC by offering additional tools and flexibility to improve how we accomplish our mission while preserving the underlying trust in us as a regulatory agency. In preparing the report on advanced manufacturing construction, we challenged ourselves to consider any ideas, big or small, with the potential to improve how we conduct our regulatory activities. The ADVANCE Act identified specific areas for us to examine as we developed the Section 401 report. The focus was on identifying any unique licensing issues or requirements relating to the use of advanced manufacturing processes, advanced construction techniques, and rapid improvement or iterative innovation processes, as those can be applied to nuclear energy projects. Each of the bullets on this slide is captured in a specific section of the report. I'm not going to touch on all of them, but I do want to highlight a few. The types of nuclear energy projects that we were thinking of as we developed the report include development of new small modular light water reactors, non-light water advanced reactors, fusion energy projects, and the range of potential new fuels and fuel cycle facilities, including the transport of fueled reactors. Across these different types of projects, we heard some unique issues, and we also heard some pretty consistent areas of interest. New processes for advanced manufacturing hold the promise of being more efficient than traditional manufacturing. Similarly, advanced construction techniques such as prefabrication, modular construction, 3D printing, and the use of robotics may have advantages over some more traditional construction. We identified that these materials and techniques are rapidly evolving and that many are not covered by the nuclear codes and standards that are incorporated by reference into the NRC's regulatory framework. The ability to accelerate the process for qualification of new materials was identified by several stakeholders as a need to support future nuclear energy projects. Within our regulatory program, we identified the opportunity to engage with codes and standards organizations on those activities and to look for opportunities to accelerate our endorsement of new standards. We also identified opportunities for new guidance to facilitate and streamline the process to request NRC approval for use of advanced manufacturing processes or materials not covered by the existing nuclear codes and standards. And I forgot to forward my slide. I apologize for that. I have mentioned stakeholders a few times, and I would like to take this opportunity to thank everyone who participated in our public meetings and provided written input as we developed the report. We held 3 public meetings with the agency's Fall 2024 Standards Forum as our first, and the second was a standalone public meeting on September 30th. We evaluated the input we received from those meetings along with the review of our own programs to develop our initial thoughts on potential actions. We followed up with a 3rd meeting on October 30th where we discussed the progress that we had made and shared our ideas for the actions that we were developing. Following our last public meeting in October, we finalized the report, which was provided to Congress on schedule in January. If you have not had an opportunity to see the report and would be interested, I provided the Adams accession number here on the slide. In the report, we identified ongoing and new activities that we believe will benefit the efficiency and reliability of our reviews. Activities provide actionable guidance that address both technology neutral as well as some technology specific topics that were identified and to enable the use of alternate codes and standards. In the report, we identified ongoing activities that were responsive by providing flexibility and supporting advanced manufacturing and construction. A number of these ongoing activities may already be familiar to you, such as the work on the Advanced Reactor Construction Oversight Program. Another activity, developing guidance to support a graded approach for seismic design for advanced reactors, is also an ongoing activity that you've heard more about already today. We identified a number of new activities. One that I would like to highlight is the development of guidance on new materials that do not yet have applicable codes and standards. Currently, the NRC does not have regulatory guidance that describes what information would be sufficient to support a request for approval for use of advanced manufacturing processes or advanced materials not covered by the nuclear codes and standards. Building on the agency's Advanced Manufacturing Action Plan, which provided a general review philosophy, we will be kicking off our effort to update and finalize our previous draft guidelines. We've identified key areas such as quality assurance, process qualification, supplemental testing, production process control and verification, and performance monitoring that will be addressed in this guidance. We look forward to additional public engagement as we begin to put the guidance together, and as with all of our guidance development, we will have a public comment period before we finalize. We're hoping for that in early 2026. The report contains more details on all of our proposed actions that are listed here on the slide, including an estimate of the cost and schedule for each. We are currently licensing new reactors. This effort is really focused on continuous improvement and our ability to license future reactors. We are looking forward to having additional public engagement on all of our ideas to improve our licensing for advanced manufacturing and construction, supporting our mission to enable the safe and secure use and deployment of civilian nuclear energy technologies. Thank you.
Thanks, Michelle. With that, I'm going to turn it over to Mirage again. Oh, look, you're already working on the second, you're ahead of me. You're working on the second polling question, and I'll hand it over to you here for just a second.
Thank you. Second polling question is, which of the following topical areas for focused NRC effort to endorse new or revised codes and standards should be given the highest priority? A, construction standards. B, material qualification standards. C, digital and systems engineering standards. D, reactor technology specific standards. So the initial is, again, option D with 40%. Is leading, followed by option B, then option A and C are head-to-head. Okay, still option D is leading, followed by option B and option C and A. Okay. Still option D followed by option B.
Yeah, that hasn't
C.
moved very much
Yeah,
at 40%,
Yep.
right? There's a solid plurality there almost for that
yeah.
option. So, all right, we're going to come back around to that.
Okay,
But
yep.
thank you. So, as a reminder for folks joining virtually, once you've logged on and joined the session, there's a tab and a Q&A box where you can put your questions in. They're going to show up here with me. For those of you in the room, I think the QR code behind me is still working, and we've been collecting questions that we're going to use with the time that we have left. So very, very interesting discussion, right, across the board. And you get a real sense for the hard and detailed work that codes and standards really entails. And I think there are a couple of themes that got touched on here. You know, Jennifer, you touched on one, and Chris did, Kate, and certainly Michelle at the end, about where's kind of the appropriate regulatory footprint, right? And if we're talking about serious deployment at scale of advanced reactors, it's possible the regulatory touch points then kind of have to change, right? Where we're talking about stamping, approving, inspecting things in different locations than maybe we have in the past. And I think this is, and I think this ties into kind of one of our first questions here. And it's a question dedicated to you, Jennifer, but I think it can be touched on by almost anybody on the panel. And it's about commercial grade dedication. And I thought that was interesting in the context of this overall discussion that we're having. And it's, can commercial grade dedication be an official tool to help in the use of high reliability non-nuclear components for advanced reactors?
Well, I mean, I would say yes, probably. The issue with commercial grade dedication is that it's a process. The applicant is hoping that this is going to work out. There may be some cost that has already been paid, and then there's the interaction with the NRC. It would be great if that, I would say, economic risk could go away by having these having these codes approved by the NRC for use under certain circumstances. So I would answer it that way. However, we do see commercial grade dedication being used in the industry today. Under 5069, for example, we also, in the case of adopting analytical tools that may have been developed by the NRC, but okay, now the vendor needs to come in and go through a commercial grade dedication process. So it's there, but having the upfront approval, I think, just would reduce a lot of the unnecessary risk, and I think would accelerate things.
Does anybody else want to jump in? Steve, you
Sure,
look like you
I
might
will.
want to say something.
So commercial grade dedication is one of the programs under the chief engineer's role, and we are using it quite a bit. We prefer to use commercial grade dedication because what it allows us to do is to, again, dedicate that important to safety function. And then we can then use commercial codes and standards for the rest of it. So our intent is to use commercial, and we are today using commercial grade dedication quite a bit. And we're using it on test articles. We're using it for lots of different things. We likely will be using it going forward quite a bit during this current procurement process. We are members of the EPRI program. 2 members of the staff are intimate with writing the EPRI documents, so we are well in tune with the commercial grade dedication and with all the regulations that are involved with it. So it is a big deal for advanced reactors today.
Well, sort of related to this, Kate, I have a question that's, I think, come in really for you. And there's, you know, I think we've heard this morning a bit about, and I think in that first poll question, about the speed with which NRC can endorse standards, right? But so what's the industry's perspective on a graded approach to endorsement as opposed to kind of an all or nothing approach? And what types of endorsement might be useful for industry in deciding whether to use a particular standard? Steve touched on this a little bit too, and kind of talking about cherry picking, I think, a little bit. But if you could kind of take the maybe take the lead on this one, and then we can have others jump in.
I'd actually like to punt this over to you.
Okay. That's entirely fair.
So repeat the question so I can answer it properly.
Sure. So what's industry's perspective on a graded approach to endorsement as opposed to an all-or-nothing approach, right? And what types of endorsements might be useful?
So a graded approach does work if it applies to what we're doing. And we are endorsing codes and standards via reg guides right now.
Yeah.
And effectively, that is a graded approach. Does it mean we can use all of a particular code of standard? The answer is probably not. But that's okay. I think we're already doing it. And in fact, we've been working with staff on what parts of the code or standard or guide, for that matter, is important to us, and they've actually been very responsive to that. So a graded approach does work. Again, and from a practical point of view, yes, there are parts of Section 11, I want to say Section 7, Division 2, Section 7, I'll get it wrong, Todd will correct me when I get it wrong. But no, we don't need all of Section 11, Division 2 approved. What we like is, quite frankly, my section approved. So if you endorse my section, I'm really great with that. I don't need it for everybody else.
I think that was the answer to the second poll question, right? It was reactor-specific codes and standards. All right. Well, thank you. No, that's very helpful. I'm gonna this next question, and don't worry, Chris and Michelle are going to have their time in the barrel here in just a minute. But this next one, it's directed to Jennifer, but I think it could be Jennifer, Kate, and Steve. And it's, we talked about risk-informing codes and standards, and as Steve noted, they're typically deterministic, and they're deterministic oftentimes for some pretty good reasons, right? But what steps do you think need to be taken to move codes and standards to a more probabilistic basis where kind of risk insights can be used to optimize codes?
I can start. I mean, it's just, again, it goes back to a graded approach, for example. So depending on the, safety significance of the particular component, what level of QA requirements do you need to have? Can you do commercial grade dedication, et cetera? So it's now you're going to have to know a lot about your design in order to do this, and in some cases you may not be able to do that right away. So there's going to have to be, I think, once you know more and you're getting your risk insights, you can go forward. I think there's also just common sense using a consequence-based approach. And in that way, again, you assume failure, and then you look at what is more important, this component or that. And in that way, to me, it's just the way that the NRC should, I think, go forward in looking at using risk insights. There's a whole bunch of different ways to do it. Makes sense to me to apply to code and standards.
Great. Anyone else?
Go ahead, Kate.
Kate?
Okay. Yeah, so if you got to start with the performance-based aspect of that. So obviously you've got that deterministic. If you want to move into risk-informed performance-based, you need to set out what are the criteria for the performance at the end of the day and begin there and then do your risk assessments. So that would be a change, and I think we've heard today that there's pluses and minuses in going down that road, and there might be some risk involved with going down that road. So,
I like it.
All right. So, two things. In some codes, either works or it doesn't, right? As in Section 3, either works or it doesn't. There are other codes and standards we use, QME, OM, AG1, where we are a risk-informed. We used to have used to be ISTE in the OM code. In the OM2 code, we changed it, and it's now risk-informed. So I think we need to be very careful what we pick and choose. I do agree that there are some codes and standards that are very easily risk-informed. It's not all. There are some that truly have to be either it works or it doesn't. Fire protection codes and standards either puts out the fire or it doesn't. There's no, well, I guess it's sort of, well, yeah, we can debate that.
I think the risk informing would come in based on the level of certainty that
Right.
the reviewer must have in making the conclusion. So in that sense, it's using a risk-informed type of approach. Again,
Yep.
it goes back to certainty.
I'll agree with that. I'll just use some sort of there are some that can be, some that can't be, is my point.
Good. Yeah, thank you, all of you. Okay, well, Chris and Michelle, because I don't want you to feel left out. So Part 53 takes a step in the right direction in moving codes from codification and the regulation to endorsement and guidance. So where, in your views, can more efficiency be gained in regulatory endorsement of codes and standards?
These are just my personal views.
I won't hold you to it.
Thank you. I think when we talk about endorsement, we look at it, we have to talk about endorse for what use? And endorse for the use of what? And I think currently, if you look at some of the policy that we have 5055A, where we've endorsed things in regulation. We also have gone through and we talk about endorsement in regulatory guides. But when I talk to a lot of vendors, what they're sort of interested in is seeing, well, what does staff think of this approach? What does staff think of this part? Is this more or less here? And that's why I personally am thinking that some sort of a graded approach, if we're able to sort of look at different levels of certainty. And if there are ways that staff's views, limitations can be done in a way that's more efficient. Because if we go the rulemaking approach and the regulatory approach, there are necessary steps to go see ACRS, necessary steps we have to get public comments in doing that, and these things take a lot of time in going through. And if we're looking for something that's more on the level of, well, is this generally going to work? Are there things that we can do to get staff's views out there more quickly? Would just be something that I would hope that we could do, and that's where the graded approach for endorsement, but again, it comes back endorsed for what use? So.
Good points. Michelle?
So the only thing that I would add to what Chris said is really the speed of our endorsement. I think it's incumbent upon us as an agency to be an active partner in our codes and standards activities, and then to prepare for endorsement in a parallel path with our work on standards organizations. And as Steve mentioned, OM2, I think that's a really fantastic example of where we participated actively in standards development and had the endorsing regulatory guidance ready to go at the same time that the standard was ready to be issued.
That's great, thank you. All right, we're going to have one last question. The little clock over here tells me I have 3.5 minutes left. I'm not sure we're going to make it, but that's only because we're having so much fun. Don't laugh, we are. This is good stuff up here. All right, but the question is really straightforward, and I guess I'd just kind of like to just go down the row and for everybody to take a stab at this. And that's, what, in your opinion, is the most important thing a given standard can accomplish?
To start off with, I guess the thing that I found a lot with standards, I'd have to say clarity. You know, because you have to make sure that the standard is clear. And oftentimes I see so much debate over a particular standard where it was written using a certain definition of a term. That term, you know, is either defined differently by another organization or another regulator. And therefore that regulator then has issues adopting it because it's definitionally different. In order to change that means a whole rewrite, and rewriting a standard, there's a whole long process to get it there. So definitions and clarity of what's meant and trying to keep things sort of in a more general approach, that to me is a big challenge. Anyway, thank you.
Yeah, thank you.
I was going to give Chris my cookie, but he stole my answer. So,
If you give a Chris a cookie, I don't know.
So I think it's clarity, but I'll add something else. And, you know, the whole purpose of a standards development organization is that you've got regulator, the industry, academics, you know, you get a whole bunch of different views coming together and in the standards development organization process, which, you know, is actually, you know, a documented decision-making process. I think having a well-balanced standards development organization on every standard that is finally generated is important.
Yeah, good, thank you.
Yeah, I would agree with both of your thoughts of clarity and that the standards are very well thought out from every different aspect of industry. So I would just add to those, that it does help to ensure safety objectives are being met, and also the consistency that industry or even jurisdictions require, both within this country and around the world. So by citing standards, you can have an assurance that those types of things are being met.
Great.
Mine's fairly simple. I want a standard that provides a reasonable assurance that an SSC will perform its intended function. That's what I want. System structure or component will perform its intended function. If it gives me that, I'm happy.
Great. Thank you. Michelle?
And I have to say, there's a downside to being at the very end of this line, but because so many things have already been mentioned. But I think from the regulatory's perspective, the benefit of the standard is that it is really a pre-aligned position of what does provide that reasonable assurance and protection of public health and safety. And so it is the most efficient, one of the most efficient ways for us to move forward in a review.
Great, thank you. Well, look at that. We are 20 seconds over, and we have reached the end of our time together. But before we go, I would just like to please give our panelists a round of applause here. And I'd like to take a moment just personally to kind of appreciate what we've done here, right? I think we've plumbed a bit the complexities associated with tackling an update of codes and standards kind of for this new moment that we're in nuclear, right? And we've seen some very deliberate approaches for that. I mean, ARCSIC and the poll of the relevant members and the gap analysis and so forth. We've got the 3x3 bucket approach that the NRC staff are taking in terms of trying to figure out how to get those near-term wins. We've got a codes and standard wish list from our friends at NEI that's very timely and relevant for where we're going to be. Steve really highlighted hey, I have to make tough decisions every day, and this is how I go about it, and this is how it works in the real world, which I think is particularly helpful as we think about how to kind of ground the effort in real licensing and real construction and real manufacturing going forward. And speaking of manufacturing, Michelle did just a great job of talking about how the NRC is starting to think about not just manufacturing of reactors, but manufacturing a lot of the things that go in reactors and what the relevant risk-informed and performance-based regulatory touch points should be. So thank you all again so much for being here. I hope you enjoyed it. I did. I really like this stuff. I had a lot of fun. Thank you all, and enjoy your evening.